Good afternoon and welcome to this UniTaster Tuesday. My name is Jon Cheek. I'm here from UniTasterDays and I'm going to be hosting this event today, where today we're going to be introducing university courses in medical and mechanical engineering. I'm delighted to be joined by Dr Elaine Brown, who's an academic colleague joining us from the University of Bradford, and Dr Louise Franz, an academic colleague joining us from the University of Hull. And we're going to cover, as we always do with these subject events, 4 main areas. Why you might be interested in studying the subject area, some application tips, an overview of careers, and also perhaps some what to actually expect on the programme. And we do these to ensure that you as a student go on to make informed university decisions. And that's what these events are always about. So whether you're joining this live or watching back as a school group, or as an individual student watching directly, a really warm welcome to you, and I hope you find this event very useful. We're going to have 2 sessions today of around 15 minutes each, and they're going to cover the 4 areas I've just mentioned. And I'm going to introduce now our first speaker. That's Dr Elaine Brown, who is a member of the academic team at the University of Bradford. Elaine's going to provide an overview of the reasons that you might be interested in studying mechanical and medical engineering, but also some application tips that Elaine might like to see when she looks at the applications for that subject area. Over to you, Elaine. Thank you.
Oh, good afternoon, everybody. And I'm delighted that you've joined this webinar, because that means that you have an interest in maybe becoming a mechanical or a medical engineer. And as I say, that delights me because the world is short of engineers. We need so many more engineers, and we need so many more people to consider becoming engineers. People who might not have thought of engineering a few years ago are now coming through and thinking this could be the career for me, and that is fantastic. So, as Jon said, my name is Elaine Brown. I am a chartered mechanical engineer. I work at the University of Bradford in the Faculty of Engineering and Informatics. And actually, I work in the Department of Chemical Engineering, but I teach engineers from all different disciplines. So that tells you something to start off with, that we have a very interdisciplinary approach to engineering at Bradford. And this is quite deliberately done because the world of engineering is massively interdisciplinary. So if you go to work as an engineer, you will most likely be working in teams with people from different engineering and scientific and clinical and industrial disciplines. So why might you as an individual want to become an engineer? There are so many different reasons why, but one of the things that I want to point out to you is that the reasons for you might be different compared with the reasons for somebody else. But essentially, a career as an engineer is hugely rewarding. What you are really doing is helping other people in some way or another. So it's a creative career. It's rewarding in terms of money. So engineers are pretty well paid, very highly paid compared with many other professions. But really, the thing that I think distinguishes it from many other careers is how rewarding it is for you as a person, because you can really develop your own skills and your own interests if you work as an engineer. So what am I going to talk to you about for the next few minutes? I know that you will be watching this webinar because maybe you have thought engineering is for you and you're not entirely sure what aspect do you want to learn about. Maybe somebody has said you'd make a good engineer, so you think, okay, I'll find out a bit more. But I know that you're watching the webinar because you have an interest already, so that's great. Probably you might be expecting me to tell you what an engineer does. I think that that's a really difficult thing to say because one engineering job is very different from another engineering job. The world of engineering is hugely diverse in terms of the need of project to solve or project to work on, but it's not that diverse in terms of engineers themselves. So actually we need to make it more diverse. We need to have all sorts of different people coming into engineering, because engineers need to be creative to solve these problems. And actually, if we have diverse viewpoints and you work within an engineering team, then we come up with better ideas. But we need more engineers because we have growing population, aging population, different things, different challenges coming along. And actually, as terrible as it is, the recent pandemic really shows us how much more we need from engineers, because engineers are required for all of the potential solutions, whether that comes to scaling up vaccine manufacture or goes through to making sure that everybody's supplied with food when lots of people are going out doing their panic buying. There are so many different things that engineers need to do to be involved. So if you are mathematical and scientific and you like solving problems and you like being creative, then you should definitely consider a career in engineering. So you've maybe narrowed it down, given that you're watching this webinar, that you think you might like to do mechanical or biomedical engineering. And actually biomedical engineering is, in many ways, it grew out of mechanical engineering, and it became something whereby a lot of the skills and the requirements of a mechanical engineer are applied within the realms of things to help humans specifically, so the biomedical environment. So you're thinking, well, I know I want to do that, but how do I get to the job that I want to have? And for many people, that means doing a degree in either mechanical engineering, medical engineering, biomedical engineering, or a combination, because some universities offer them as a combination. When it comes to choosing which university you want to go to, then there are some tips that I've put together to maybe like a little checklist for you to go through to think, right, these are the things I'm looking for. When you've done that, you can then incorporate a lot of those ideas into your personal statement or your reasons. So if you go for an interview or an applicant experience day, you can talk to the tutors, and it will really bring out the fact that you have thought about why you are choosing their university. Because we don't just want to be taken from a list, we want people to choose us because they know that they want to come to us. And that would be the same for all universities. We want to take students that we know will be good for our courses, but more importantly, our courses will be good for them. So an engineer essentially turns ideas into reality. When we work as engineers, it's different from being a scientist. So a scientist might come up with some thoughts and think, well, this works and that works, but they don't necessarily think about how they can be used. An engineer starts with the problem. So we know that we need to provide clean water to this city. How do we do that? And we use the scientific and mechanical principles to help us to solve that problem. So an engineer you have to be quite pragmatic. Sometimes you might come up with some fantastic ideas, but actually they might be incredibly expensive or not very sustainable, or you might need lots of raw materials, but you have to ship them all the way around the world. So as well as coming up with good ideas, you also have to think of the wider picture and think about how those ideas could be turned into reality. And that will help you with the checklist. And you can apply that same reasoning to when you're thinking about which university you want to choose. Think of all of the requirements, put them all together. Don't have one above the others. Think about everything that might make that university course good for you. So you want to choose and apply to a university. I think a good place to start is to think about what makes a good engineer, because if you know what makes a good engineer, then you can work out where your skills fit in the world of engineering. You can work out what things you're good at and maybe what things you need a bit more work on, and that can help you to choose the best university course for you. So really, an engineer, we have to like solving problems. We have to, because we tend to start with the problem and then work backwards to find out how to solve it. So sometimes we have to work out how things work. That could be a system or it could be a physical thing. Really, many engineers have to work with other people. There are some roles that you can work independently and individually, but the majority of roles you work with other people. So you have to be able to work in teams and in groups, in addition to taking individual responsibility for your own part of work as well. You do have to have good maths and science skills. That is something that in order to get into an engineering course, you tend to have A-level maths plus a science, at least one science. But again, you need to be able to develop those skills during your course. But you have to be curious, you have to be open-minded, you have to be ready to think of different ideas and to maybe take them on board. The word engineer, I think it's quite interesting. I didn't do Latin at school, but actually I've found out since that the word engineer comes from a Latin term, ingeniare, which means to contrive or devise, or ingenium, which means cleverness. Which is quite nice as an engineer to describe yourself like that. But really, what I'm saying is you have to be able to take information, to work methodically through the information, use certain skills in order to solve the problems. And that really is the definition of being clever. And at Bradford, we have 4 main types of engineering. So we have mechanical, civil and structural, chemical and process, and then biomedical engineering. And I know when Louise talks to you in a moment about the courses at Hull, that Hull is set up a little bit differently. But fundamentally, a lot of the university courses are set up such that engineering students are provided with the skill development. So we give you the knowledge, the fundamental knowledge as well, but an engineering course is different from a science course because of the skills and the analytical approaches and the situations that you are put in as an engineering student that help you to develop those skills. So you might look at lots of different universities and think, how do I know that Bradford would be the best one for me? So this is just a list. You don't have to follow them all, but I thought it might help you. So I will go through each one of these things in turn. You want to think about accreditation. You want to think about the course content, how it's taught, how many students are on the course, how much practical work you get to do, the amount of investment the university has made in students, the industrial or clinical links. If you're doing biomedical engineering, clinical will be as important as industrial, how satisfied the students are, whether or not there are extra opportunities. And then one thing that I think you can use to differentiate from one university from another is the research that the staff do at the university. And if you think about all of these things, that will help you when you're forming your application to that university. So a quick note, make sure that you consider your path and know that if you want to become a chartered engineer, you have to be educated up to master's level. So you can either do a BEng and an MSc, or you could do an MEng course. And the MEng course is a quicker way of doing it. It's a 4-year course unless you do a placement, which I would always recommend. I'm not going to talk about placements today, but I would really highly recommend a placement. But if you want to become chartered at the end of well, not at the end, but within your career, then you need to have the master's level course. So start thinking about it now. There are different routes to it, but this is something that you ought to bear in mind. You need to make sure that whichever university course you choose is accredited if you want to become chartered. Most courses are, but some are not. So just be careful, make sure you ask that question if it's not clear from the information that they provide. Now, for mechanical or biomedical engineering at Bradford, our courses are all accredited by the Institution of Mechanical Engineers. So we know that if students complete their masters at Bradford, then they can use that as the part of becoming chartered, so the academic part of becoming chartered. If you want to become chartered, you also have to have experience post-graduation, and you would work with your Institution of Mechanical Engineers in order to get there. So the next thing on my list was, what about the modules and the module choices? So some universities permit choice, some don't. Some allow choice in their second year, some only allow it in their third or fourth year. What I would say is, if you look at the modules on a course, what you might find is that modules from one university to the next might have different names, but fundamentally, most of the modules will have the same content from one accredited course to the other, apart from maybe the optional modules, because that's where you can maybe do something that you're particularly interested in, but those optional modules will still bring through the same skills. So I probably wouldn't worry too much about the particular module titles. I would say that if a course is accredited, then you can be guaranteed that everything will be covered, but you will be doing things like mathematics and applied mathematics and different scientific subjects, as well as more kind of project-based subjects. So at Bradford, we run our first year as an interdisciplinary first year, which I mentioned earlier, and we do that because we want our engineers to talk to each other, to talk each other's engineering language, and it puts people in a situation that's more typical of life beyond university. So we have lots of modules that are common to all first year engineering students, but then their individual projects might link specifically to whichever engineering discipline they've chosen. And then when you go through to your second year, then there's lots more fundamental modules, and third year tends to be a lot more project-based modules and bringing out some optional work as well. The next thing on my list of tips was about how the engineering is taught. Some universities have very, very traditional teaching where everything is still very set in lectures and tutorials only, whereas more modern university teaching for engineering tends to do lots more work on actual project solving, because as an engineer, you tend to have problems that don't have a right or wrong answer. There are many answers, and it's about working out the skills to get through to that answer. So at Bradford, we use something called the T-shaped professional when we're designing our courses. So you have a real in-depth knowledge of your area, but you also have an overarching knowledge and set of skills that are useful for all engineers. And we use something called CDIO, which stands for Conceive, Design, Implement, Operate. And that's all about bringing out the engineering skills. So if you're looking to compare between universities, find out, it might suit you better to sit in a lecture, it might suit you better to do more hands-on work. And what you need to do is work out what's good for you, what suits your personality and your learning style. And I can't say what would be the best for you, but what I can say is that an employer looks for the kind of skills that this type of teaching brings through. The next thing, cohort and class size. Some universities take hundreds and hundreds of students onto a course, and within that course then you can feel quite anonymous, but actually that does suit some students. Some students like to be just one of many. What I think is really important, however, is that if you're at university, you've got really good access to tutors. So my preference would always be for a smaller cohort size so that you get a very good interaction with your tutors and you can talk to your tutors. So you need to think about that. What do you like the best? So at Bradford, we tend to have relatively small cohorts, so about 80 students per course as a maximum. Some courses have fewer. And that means that we get to know all our students. So I do think it's quite important that our students can then engage with us. So you see, with the pictures here, you can see if you've got smaller class sizes, then you can get much more hands-on experience, which helps you to bring through all the skills that the employers are looking for. And so just got a couple of pictures here. You can see some of our students working in small groups in the labs. Here's some biomedical engineers that are doing some cell culture, but also doing some testing of a hip replacement part. Some mechanical engineers, so they're testing some turbines that they've made and they've built themselves using the 3D printers, some other tools, and they're testing them in the wind tunnels. And here, this is a transporter project where they're trying to get a transporter, or trying to transport a load. So these are small group projects. If we have thousands of students within a university, it's much more difficult for university to get students working in groups like this. So if there are several hundred students on a course, you might have a different experience. It might be the one that you prefer, but you need to think about that. Think as well about how well the university is invested in its students. We've got lots of big labs at Bradford where we've got plenty of space for our students to get involved and get hands-on. You can look at this information in lots of the league tables. You need to look at the external links, so it might be industrial links, clinical links. You want to think about whether or not that university has taken into account what employers are looking for. So for example, we have industrial advisory boards and they help to develop some curriculum ideas and they give us projects and things like that, so that we know that our students are working towards things that industry will really want. You do need to think about what students think. So for example, every year there's something called the National Student Survey, where students are asked about what they think about their course. And the most recent National Student Survey, I'm happy to say that for my department, the students on chemical engineering on the placement came up with 100% satisfaction in the course. The reason is for that, I think, is that they do have very, very good access to tutors. So I think when you're going to look around universities, when you go to the open days and when you go to meet people, make sure that you're actually meeting the tutors who will be teaching you and speak to those tutors, because universities are big places. You might just speak to people that you're not really sure whether or not they would be involved in your own education. So make sure that you ask that. Look at the league tables. I would say you need to look at the detail of league tables. It's really important that you don't look at them just as a general measure, because they measure so many different things. Some league tables include research, and in some of the universities that research does not help the undergraduate students at all. The Guardian League table is pretty good for undergraduate studies. You can look at those league tables and you can see from there how satisfied students are, what the value added measure is for students on those courses, and what the investment is, what the graduate prospects are. But look at each of those columns in turn. Don't just look at the overall measure, and think about what means the most to you, and then take that as being your next step in terms of choosing your university. Look as well for some curriculum linked opportunities. So for example, we have things like students who can enter competitions and they can do things on their course that then help them with the extracurricular stuff. For the mechanical engineers among you, we also do Formula Student, where students can they use the facilities at the university to build their own racing car, which they then take and race against other university students. And if you are particularly interested in things like Formula One, just to point out one of our alumni from Bradford, Stephanie here, she was recently the first Black woman on a winning podium at a Formula One race when she went onto the podium with Lewis Hamilton, because she works with Lewis Hamilton. So that's another thing that you could do. Look at the alumni of the university that you're interested in and see what kind of organisations they go to work for. People sometimes are surprised. So we at Bradford send students to all of the major companies that you can think of. So our alumni are in all these companies. And then you can, if you look at things like LinkedIn and this type of information provider, you can find out, if you go to a university, what kind of place do their graduates go to work in? And this can be quite a nice way of thinking whether or not it suits you. The last point on my tick list is to look at the research. So at Bradford, we have research-led teaching. We're quite a small university, so all the people who teach our undergraduates also work as researchers, and we bring that into our teaching. So we have the research skills, but also the research projects. So you can see here the lab that I work in is called Advanced Materials, and we have both mechanical and biomedical engineers, and actually other engineers working in that lab. So we bring that research into the final year projects, for example, and actually into some other projects that students do. And that's the research lab that I am in most of the time if I'm not having to work from home during the pandemic. One extra thing to note is how applicable a university is to the world around us, because as engineers, we want to make that difference. So, for example, during the COVID pandemic, it became really apparent that engineers are hugely required to help us. And one of the things that we did at Bradford was we used our facilities to make hospital-grade PPE that could go out to the doctors and to the nurses and to the other health practitioners. And this is something that can really make a difference in a university. Universities are not just ivory towers, as they're sometimes called, which is just for learning. At Bradford, we have this motto, making knowledge work. So it's about making our engineering knowledge work for people outside of university. And that's another thing you can do. Look at what that university does for its local area, for its city, and for its the people that live nearby. So that brings me to the end. It's a bit of a whistle-stop tour. I know it's quite quick and I've been talking quite rapidly, but hopefully that will give you some ideas of what to look for and what questions to ask that you can then use when you're forming your own applications to a university, and it will show that you've really thought about it. Thank you.
Thank you very much, Elaine. What a brilliant start to the event, looking at mechanical and medical engineering. And a big thank you again to Dr. Elaine Brown, who's joined us from the University of Bradford. Elaine, if you don't mind just clicking stop share, yeah, you've done it, it comes straight back to me. Really appreciate that, Elaine, thank you. Our next speaker today is Dr. Louise Franz, who's joined us, again, an academic colleague, but joining us from the University of Hull. Louise is a programme director on the medical engineering programme, but also a lecturer in mechanical engineering as well. And Louise is going to talk about what to expect on a course in this subject area, and also provide a guide to some of the career opportunities students go on to do as well. So Louise, over to you, please.
So yeah, thank you for the introduction. My name's Louise, and I'm actually the Director of Student Experience for the Department of Engineering at the University of Hull. So like Elaine, I've got a bit of a mixed background and I teach across many different engineering programs. So I just want to start with a slide to show you just how people perceive engineering. So this is kind of how I sum up what I do, or what people certainly think I do. Engineering is so diverse, it really is, and it really is what you make it. Obviously, all my friends think I'm like the cast from Big Bang Theory. I get to play with really cool things and do new stuff. I get to play with equipment that's quite expensive. I hope I don't break. Other people think engineering is just full of maths and it's really hard. Engineering is quite hard, but the courses are set up to guide you so that you can get through it. Obviously, society has its own stereotypes as to what they think engineers do, but we literally get involved in all walks of life as long as it requires logic, problem solving, then an engineer will be there. Lego, everyone loves Lego, engineers love Lego, and obviously then there's my own perception of what I think I do. Because I'm a medical engineer, obviously I think I'm like Iron Man and I can fix all these things. But what I actually do is quite different, and I don't want to get into too much detail about what I do, but what I want to show you is what you can do and the kind of stuff you will do at university. So the first question to start with is, what does a typical engineering course look like? And the short answer is there's no typical engineering course. Every university delivers their course in a very different way. And like Elaine said previously, that's why it's really important to have a look around and try and find something that really suits you. There are universities that will deliver an engineering course in quite a theoretical way, and there are universities that will deliver an engineering course in quite a practical way. You have to find what suits you. You're going to commit yourselves to 3 or 4 years on a course, and you need to make sure that you're going to enjoy it. However, saying that, there are several things that all of the engineering courses will have in common. And the first one I want to start with is contact hours. So you may have heard people say that if you do engineering, you're going to have a very busy timetable, you're going to be in lectures all day, every day. And in one respect, that's quite true. So typically across the sector, you will have 20 to 30 contact hours a week with your lecturers and your tutors. If you compare this to other courses, that's considerably higher. I always tell my students to not compare themselves to people on other courses because it's going to look like they don't have as much free time. But I like to think of it as value for money. So you're paying for your tuition fees and you get to spend most of that time in a lab, in a lecture, in a computer room, doing something and actually learning. So just be aware, it is full on, but it's also a lot of fun when you're in. So it's not all just sitting in front of a lecturer and presenting slides like this. The timetable is quite different to what you might be used to at school or college. So we no longer have terms. We split our year up into trimesters or semesters, depending on the institution. If it's a trimester, then there are essentially 3 blocks of teaching. And if we're in semesters, then there's 2 blocks of teaching. So typically your trimester will start at the end of September after we've had Freshers Week and invited you onto campus. And then there will be 10 to 12 weeks of teaching. And in college or school, you would normally have a break halfway through where we let you go home. Unfortunately, that doesn't exist in most institutions. We like to teach the full breadth of that 12 weeks, and then we will let you go home for your Christmas break. You then return after Christmas, and you would typically have a couple of weeks for exams, and then we would finish that first trimester and move on to the second. And that will run in a similar way, where we then teach right through from kind of end of January, February through to May. You'll have your break for Easter in the middle and you'll finish with your exams. But then the nice thing is you get a good 4 months off for summer, which gives you opportunities to either secure an internship, to get work placement, or even to go traveling. So it really does play into your university experience. But it is a very different way of learning. It's a different way of teaching. And you have to get used to that big long slog of 12 weeks. So Elaine mentioned that all the programs are slightly different at every university, and that's something that I really want to stress. The stuff I'm going to show you now is typically what we offer at Hull on our degrees, and we are accredited, so all the topics that are listed on these program structures are typically governed by the IMechE or the IET, but there are some options in there that we run for our sake as well. So just to give you a rough idea of what your degree would look like, the kind of things you'd be doing. So in your first year, so this is level 4, this is the certificate stage. We're split here into trimester 1, trimester 2. The way we run our courses, you'd be doing 3 topics at once, so 3 modules that run in parallel. And you'll notice that maths is a theme throughout the whole of an engineering degree. There is no escaping maths, but that's not a problem because we all love maths and we all love the application of maths. That's why we chose engineering. So typically we would be looking at maths, we would be looking at mathematical tools, which includes using different softwares such as MATLAB to look at programming, that kind of thing. The fundamentals of mechanical engineering would be building up your statics knowledge that you'll have from A-level maths and your mechanics. And then the favourite one for all mechanical engineers is looking at engineering design. Now at Hull, we're very hands-on. So this module is split up so that we teach you how to use CAD. So we use SolidWorks as our package, and we teach you how to draw, how to design. And then for the second half of the module, we actually put you into the mechanical workshop and you manufacture the things that you've drawn. That is quite unique. And if that's the kind of thing you enjoy, then maybe you should be looking more towards a practical based course rather than a theoretical based course. But have a look around, every university is slightly different. In your second trimester, again, engineering's there and we start, maths is there, and we start applying that a bit more now, looking at thermodynamics. So some of these words may seem really scary at the minute, they're really not. And once we start teaching, obviously, they will make more sense to you. We do a lot of material science. Material science underpins quite a lot of engineering. If you are really good at maths, but you don't understand the material science, then your applications are going to be quite limited. One of the big themes at Hull, and all the boxes that are coloured in yellow, are to do with group work. So as an engineer, you're going to go out into the real world, solve real world problems, and you're going to have to work with other people. And those other people won't necessarily have the same skill set as you or the same knowledge as you. So you have to learn how to communicate your ideas effectively. You have to learn how to give constructive criticism, but also how to receive constructive criticism as well. And we make sure that every year there's group work modules that force you to develop these skills, because these are the skills that our employers are looking for. So your first certificate stage is literally giving you the fundamentals of an engineering degree. And at Hull, we're the same as Bradford. It is an interdisciplinary year where, regardless of whether you're on mechanical or medical or biomedical, you all do the same thing. And as you move on to your diploma stage, we start to apply those fundamentals a bit more. So again, we've got a bit more maths, but we've just increased the difficulty. And I would say for most engineering degrees, the second year is the hardest, because you've settled into university, you know how things work, and this is where we really start to ramp things up. But again, it's the same streams that run through the programme. You've got your maths and your application, you've got your group work, you've got your design, and you've got your materials. The actual names of the modules will change from university to university, but the actual content will be quite similar. Once you hit your honours stage, which is where if you've chosen to do a BEng, this is where you'll graduate after, or if you've chosen to do an MEng, this is your penultimate year. So your third year is really where you start to specialise. This is where you really start to apply the knowledge that you've got to start becoming a professional engineer. So you'll notice that there's an engineering project. Every course will have an engineering project at this level. This is where you get to pick a topic that really interests you, and it really allows you to apply your skill set and your knowledge to really push yourself and do something meaningful. So at the University of Hull, we're quite lucky. We've got a lot of industrial partners, and we're in an area that allows us to pull in quite a lot of input into these projects from those industrial partners. So every project that we offer is linked to live research, which means that the stuff that you do is actually meaningful and has the potential to actually make a difference, which is what we're trying to do. So once you hit your master's stage, obviously this is where you're really separating your skill set between the BEng and the MEng. This time, your modules are a lot more self-guided. The onus is on you to do a lot more reading to be able to apply your skill set. And you'll notice at Hull, we have a group project. So there's no escaping group work. It's right there from the beginning of your course to the end of your course. So for medical engineering, as I mentioned before, we've got an interdisciplinary first year. So it's exactly the same. Medical engineering grew out of mechanical engineering. So you'll notice that there's quite a few themes in there that we've just seen on the previous slides. However, we now start to apply those mechanical skills in a medical setting. So you'll notice that we've got modules on there such as physiological measurements. So we're starting to take measurements for the body using biomechanics, etc., and trying to figure out how we apply the maths to create those calculations. We've got modules that are linked with the NHS. It's really important that our students appreciate the medical engineering devices and technology that's currently being used in the NHS, because that's the stuff that they're going to be working on when they graduate. And then once you hit year 3 and 4, again, it's a lot more specialised. And for us, this is where everything switches to medical engineering. This might not be the case everywhere, so make sure you look at all the different programs, because everyone has their own plan. For us, we really focus on 3 main themes. So we have materials that run through our program as well, but this time in a medical setting. We have prosthetics and artificial organs, and we have an element of design and medical imaging. For us, it's really important that our students have a real broad knowledge, so that we are making you a rounded medical engineer, because that opens up many more opportunities for a career afterwards. So how are you going to be taught on an engineering degree? So again, this varies between university, but overall I would say this is quite a generic list. So obviously there is the traditional lectures. At the minute, during this pandemic, everything's a little bit strange, and most universities are now delivering their courses online with minimal face-to-face on campus. So for us, all of our lectures are online, but we're still running labs, but with much smaller groups. We have online platforms that will help you to learn. So we use a piece of software called Canvas, and we use Microsoft Teams as well. But because we're engineers, we're quite practical. We like to talk and we like to solve problems. So there are problem classes. You do have small group tutorials, but we have a lot of laboratory sessions as well. I would imagine most people that apply for an engineering degree like to mess around with things and figure out how they work, and we want to play on those strengths. So you'll spend quite a lot of time in computer labs as well, learning computer software. And as I mentioned before, there is no escape from group work. So we try and put you into small group work rooms, which we're actually doing online at the minute, to make sure that we can bring you together and give you a space to work as a group. At Hull, we're quite lucky. We've got a mechanical engineering workshop where we've got lathes and mills and CNC machines, etc. So we put all of our medical and mechanical students through that as well. We are not training you up to be technicians to use those pieces of kit. We are training you to use that kit so that you can appreciate the design process behind the medical devices that you're going to be creating. So you can have the most amazing invention, the most amazing design, but if we can't manufacture it, then it's pointless. So that's what we're trying to show you there. So why are we going to teach it this way? Basically, we want to give you the skills to go out into the world and to be an engineer. And if we just taught you via lectures, we're not really doing you any service. We're not training you to just sit and listen and absorb information and pass an exam. We are teaching you the practical skills that are required in the real world to be an engineer. So using industry level software is really important. Every institution will be using a different kind of software, but it will all be industry level, and all of your courses will be supported with the labs and the workshop style teaching as well. So for me, it's not about knowing that you can perform a tensile test on a material. It's about knowing that you understand why we would do that. And the easiest way to understand why is by giving it a go. So as you can see on the right-hand side of this screen, this is one of our teaching labs. And one of our first year group modules is actually designing an airship that will travel down the length of this lab. So we bring you here into this space and we make you work with people who are not in your own degree specialism. It forces you to talk to other engineers. It forces you to pick up new skills, but it forces you to also communicate your ideas successfully. So these are the skills that employers are looking for, not just the technical information that you pick up as an engineer, but these soft skills as well. So I'm just putting on the bottom here that we're trying to turn you into a real world engineer. We're not trying to train you to pass exams. We want you to be able to use your skill set. Elaine touched on this quite a bit, but I think it feeds in nicely as to why your degree is shaped the way it is. Any reputable BEng or MEng program will be accredited. At Hull, our medical program is accredited by the IET, the Institute of Mechanical Engineers, and the Institute of Physics and Engineering and Medicine. Our mechanical engineering degree is accredited by the IMechE and the IET. That is just a sign of quality for the programs, and it also means that you're one step closer to achieving professional engineering registration when you finish. So as Elaine mentioned before, always ask the question of, are your courses accredited and who are they accredited by? Which leads on nicely to, what do you do with your degree once you've got it? So you can do pretty much anything you want with an engineering degree, within reason, and you'll be paid well to do it. The world needs more engineers, and the skill set that we give you opens you up to a whole host of opportunities. So we set you up with quite a high level of technical knowledge. If you choose a university that has a degree with a very specific specialism, then obviously you're setting yourself up for a career in that area. If you take a broader degree, such as mechanical engineering, then you're going to have a whole range of skills. But we're also making sure that we give you these soft skills, such as logical thinking, critical analysis, teamwork, communication. And this is the skill set that's sought after by most employees, which allows us to move away from a traditional engineering job to a whole host of other opportunities. So what can you do with a degree in mechanical engineering? So this is the kind of stuff you'd find if you were to Google that. Obviously, you've got to pick something that you really love, and with your broad set of skills, the world is your oyster, it really is. We have people who stay within engineering, looking at the stereotypical automotive, aerospace, robotics, energy, medical devices, even if you're from a mechanical background. But we also have people who transfer over to finance and business and management, or research development, government advisors, people who look after intellectual property, etc. It really does depend at what stage of an engineering process you would like to work at. If you choose medical engineering, it's exactly the same. You've got such a diverse skill set that you can choose pretty much anything you want. But most of our graduates go on to work in companies that design and develop, manufacture medical devices. They can work in sales departments selling the medical devices because you have that knowledge of how these devices work, and you can go out and you can convince surgeons and consultants that these devices are definitely what they need and why. We have people that work actually in hospitals, and they provide a non-clinical service. So you can go on to be a clinical engineer or a clinical scientist, and this means that you are using your engineering degree within the NHS, within a private hospital, to develop new technology that enhances the treatment that they're able to deliver. Quite a few medical engineers choose to stay in academia, or they go into government research facilities. So this tends to be the cutting edge, brand new research, the what's coming next, the stuff that's not available to anybody else yet. Again, we've got patent offices, but more importantly, just as I mentioned with the mechanical engineer, you can go on and get professional chartered engineer status. For most engineers, this is what we're aiming for. If you move out of a university setting for a job after, and you've got chartered engineer status, you are basically guaranteeing your employer that you are a recognised international standard with your engineering skills, and that's what we need. And chartered engineers have got a kind of a place in the world where they can argue for a better pay, etc. So it's always worth fighting for. So I realise we're kind of running out of time. So just to loop back to where I started, your engineering journey will be specific to you. Pick something that interests you, not because it's something that your friends are doing, but it's something that you really want to do and something that you want to invest your time in. And you really can make it whatever you want it to be. So that's the end of what I wanted to say. So thank you for listening.